Good morning. This is Mr. Sandin once again. I'm even going to let you see my face. All right. So today we're going to do 12.2 functions of any angle. Now when you're working with functions of any angle for trig functions, you need to know where to start. Your initial side of your angle is always on the positive x-axis. And then for a positive angle, we're going to go counterclockwise around until we get to the terminal side. So this is your initial or starting side, and this is your ending side, your terminal side. So it goes around like so. If I wanted to draw something that was only 80 degrees, how about negative 80 degrees, negative 80 degrees, I'd still start in the same spot, the initial side, but instead of going counterclockwise, I'm going to go clockwise until I get to 80 degrees. So this would be negative 80 degrees because I went counterclockwise. Now, what if I wanted to go 1,000 degrees? Well, first I need to start with my XY axis. I've got my initial side, and then here's where it gets kind of fun. It's going counterclockwise. Well, that's 360. If I go another circle, that's 720. So if I say 1,000 minus 720, that's 280 degrees left. Well, each 90 degree, right? So 90, 180, 270. So I have to go just a little bit past. Probably should have done that in a different color. Just a little bit past that. So that's only 10 degrees past that. Well, guess what? This is only 10 degrees before the 270, the 90 degree angle. So these two, positive 1,000 degrees, that's going 1,000. That's going all the way around twice and then ending here, a little over 3/4 of the way around. And negative 80, this is what we call coterminal. That should be a lower t. Angles. Coterminal angles, where they end, their terminal side is in the exact same position. Now let's look at another couple of coterminal angles that we can find without having to draw them out. But this is how you draw angles. Negative degree clockwise, positive degrees go counterclockwise. If it's more than 360, you draw the swirl to show how many times you've gone around. All right, let's get rid of this and we'll talk about coterminal angles. If your initial angle is 60 degrees and you want to find one that's coterminal with it, you could add 360. That brings it all the way around once, right? So that would be 420 degrees. That's one coterminal angle. And typically, we want one positive and one negative coterminal angle. So if I said, instead of adding 360, if I said minus 360, that would give me negative 300 degrees. So there's my two coterminal angles. Got this one and this one. Those are my two coterminal angles. One positive, one negative. Let's look at another example of that. What if I start with negative 400 degrees? Well, if I add 360 to that, that gets me to negative 40 degrees. But that's still a negative angle. So I don't want to subtract 360. I mean, that will give me a coterminal angle. That would be negative 760. But I want one positive and one negative. So I'm going to have to take my negative 40 and add 360 to it again so that I come out with an angle that is positive. When I add these up, that gives me 320 degrees. And now I have one positive and one negative coterminal angle. All right, let's look at something else. What happens when I want to find sine, cosine, tangent, maybe secant, cosecant, I'm not sure what it asked for. Oh, it just asked for sine, cosine, tangent. I'll show you all of them anyway. But if I were told that the terminal side of an angle, was at the point negative 24,7. So here's the point, negative 24,7. If that's the terminal side of my angle, that's on the terminal side. So if I drew this out, I could draw a line down and over. Now, we know that this is theta. But when we actually work with these, I want a right triangle angle. And that's more than what I want, and that can't be. So the theta I use, I drop this down here, and this is going to be my triangle where theta is right there. When you use this is called, what do we call that? Oh, there's a name for that. It'll come back to me. I can't think of it off the top of my head. But there's a name for that type of angle. Object. I knew I could come up with it. That's the object angle. So I'm going to use this angle instead of this one. True, they will come out to the same trig values, whether I use this one or this one, but because of these signs, it's going to make a difference here in some of them. And you'll see what I mean in a second. So this is 7. This distance is 24. I need to know what this distance is. Let me just erase this a little bit so we have room to put it in there. If we made a circle with this as the radius, okay, this is always going to be positive. A radius is always positive. So we're going to call that r. We know that this is the x value and this is the y value. That's negative 24 in distance. So negative 20, so x squared plus y squared equals r squared. So negative 24 squared plus 7 squared equals r squared. It turns out negative 24 squared is going to be a positive 576. And 7 squared is 49. So r squared equals 625. That means when I square root both sides, r ends up 25. So if we now know that r is 25, I can start setting up my proportions, my trig ratio, excuse me. So sine of theta is going to be opposite the y value over the hypotenuse. So y over r. Cosine is going to be adjacent over hypotenuse, x over r. And tangent of theta is going to be opposite over adjacent, y over x. Now, this is kind of important that you see these, y over r, x over r, y over x, because then you don't have to draw this out and draw where the object angle is. You can just plug in, find r, it's always the hypotenuse. You can just plug these in from the point x, y, and r, and you can just plug them right in, and it'll make it much easier to do. Now, we also know that cotangent of theta is going to be x over y. Secant of theta is going to be r over x. And cosecant of theta is going to be r over y. All right. Now let's just fill in the values here. Let's see. We've got 7 over 25. Negative 24 over 25. Let's see. We've got y, 7 over negative 24. Negative 24 over 7. 25 over negative 24, and 25 over 7. All right. So the next thing I want us to think about, using this information, which I wish I could just slide that over, but I don't have that ability now. Let's just erase this. Let's erase this. And let's see. Just thinking sine, cosine, tangent. I want to know what sign it's going to have in each quadrant. Now, we don't really need these over here because we're not focusing on that at the moment. We are just focusing on sine, cosine, and tangent. In the first quadrant, everything is positive, so all of these are going to be positive. In the second quadrant, what's positive and what's negative? Well, r is always positive. X is negative, y is positive. Negative, positive in the second quadrant. So x is negative, everything else is positive. That means everything with an x in it is going to be negative. So sine is going to be positive, cosine and tangent are negative. In the third quadrant, both x and y are negative. So that, and r is always positive. So that's going to be negative. That's going to be negative, but a negative divided by a negative is a positive. So this is going to be negative, negative, positive. Sine, in the fourth quadrant, what's positive, what's negative? X is positive, y is negative in the fourth quadrant. So if that's the case, y is the thing that's negative. So negative, positive, negative divided by positive is a negative. So negative, positive, negative. Now, one of the ways, without seeing this whole chart, that you can remember this, I've heard it before, but my pre-cal teacher at Fitchburg State, UMass, got to get it right, at good grief, Mount Wachusett, said this, and you remember it, all students take calculus. Now, that's not what's important. What's important is, of these three, all are positive. All are positive, sine is positive, tangent is positive, and cotangent is positive. So first quadrant all, second quadrant only sine, third quadrant only tangent, and fourth quadrant only cosine. All right, one last thing for us to talk about, and that is what happens when it's not in a quadrant but on an axis. So what happens, for example, when theta equals 90 degrees? Well, if it's on what we refer to as a unit circle, the radius of a unit circle is going to be 1 unit. Now, it could be any number, but let's use 1. The coordinates for that point are 0, 1. So when I find sine of 90 degrees, let me write that better. That's going to be y over r, 1 over 1, which is 1. Cosine of 90 degrees is going to be x over r, and anytime 0's on top and any number is on bottom other than 0, it's 0. And finally, you've got tangent of 90 degrees. That is y over x, 1 over 0. Anytime you divide by 0, it's undefined. So your assignment for this section is page 656. That's where it starts in the book, not the PDF. 656. So in the PDF, you're going to have to find the page of the book, 656. 16 to 66 all. Skip